Arithmetic and geometric sequences. Discrete data sets. Discrete data are quantitative data that involves distinct separate values. In our last lesson, we said that if the data is counted, then it is usually discrete data. For example, how many people are on a plane? That would be a discrete set of values. A sequence is a discrete list of numbers. In this case, we'll concentrate on numbers starting in the first term and moving on. Technically, we would call this a discrete set using our academic vocabulary. The set would be the natural numbers. So each term will be the individual numbers in the sequence. Remember, because we're talking about a set here, the individual number can also be called an element. Now, the nth term is the equation that defines the sequence, and that really only applies to the explicitly defined sequences. So there are two ways a sequence is defined: explicitly, with an equation that gives the answer to each individual term with n as the variable, and recursively, with a formula relating the term to the previous terms. We say a sub n or a sub n minus 1 as the variable. Let's start with some explicit examples. Find the first 5 terms starting at the first term for the following explicitly defined sequences. So we have a to the n equals 5n plus 2. When it says the first term, that means that you're going to use 1 for n. So basically we just say a sub 1. That's simply telling me which term I'm on. Equals 5. Now because we put the 1 here where the n goes, we're going to put the 1 here where the n goes. Plus 2. Then we just do the math. 5 times 1 is 5 plus 2 is equal to 7. They want the first 5 terms, so we do it again. A sub 2 is equal to 5. Instead of writing n, we wrote 2, so we put 2 plus 2. That gives me 10 plus 2 is equal to 12. Now we're going to do this for the first 5 terms. So we're going to do a sub 3, a sub 4, and a sub 5. So the first 5 terms would be 7, 12, 17, 24, and 27. Now, one thing I want to point out, they said here to start at the first term, so we used a number 1 for the first term. They could have said any number. They might have wanted to start at the 0 term. They could have asked to start at the 10th term. Whatever term they ask us to start at, we already have the equation. We simply plug that number in for the n. For example, if for the next one, instead of starting at the first term, they said start at the 7th term, then we're going to start with a sub 7, which is going to give us 7 squared minus 1. That would give us 49 minus 1 is equal to 48. And then they want 5 terms still, so we would say a sub 8 would be our next one. 8 squared minus 1 is equal to 64 minus 1, which is equal to 63. And we would keep doing this for 5 terms. So the first 5 terms of a sub n equals n squared minus 1, starting at the 7th term, are 48, 63, 80, 99, and 120. So it's always important when asking for an explicitly defined sequence that we make sure we look at what term they're asking for to begin with. They can ask for the first term, they could ask for the 0th term. That's as far back as they can go. So it's going to be any of the whole numbers. Remember, whole numbers start at 0 and are 1, 2, 3, 4, etc. Some more vocabulary. Realize we started at the first term. This is my first term, this is my second term, this is my third term, fourth, and fifth. If they ask for the third term, I would say 17. Now over here on the bottom one, this is the 7th term. It's my first element in my list, but it's my 7th term because that's where we started at, the 7th term. 8th term, 9th, 10th, 11th. So if they ask for the 3rd term, I don't have that on the bottom list. If they ask for the 10th term, then I can simply go over here to 99 is my 10th term. So make sure you understand the difference between the element, which is the number in my list, so my first element and my second element, versus my terms. I started at 7, so 7, 8, and 9. Moving on to recursively defined sequences. When you have a recursively defined sequence, they need to give you an a sub 1, meaning your very first term. They may also give you 2 other terms where you have to go back and you have to find that first term. We'll get to those later on. But for now, a sub 1 is equal to 3. They want us to find the first 4 terms, and we're given the first term. So that means we only have to find 3 more. So we already have a sub 1. A sub 1 is equal to 3. Now we need a sub 2 is equal to 2 times a, where there's an n, I put what I put for the n. 2 minus 1 plus 5. Well, what is 2 minus 1? That's a sub 1 plus 5. 2 minus 1 is 1. Well, do I know what a sub 1 is? Yes, we already know what a sub 1 is. It's 3. So where I have an a sub 1, I'm going to put a 3. What that gives me is 2 times 3 plus 5 is equal to 6 plus 5, which is 11. Now when I move down to a sub 3, that's going to be 2a. Instead of a 2, I have a 3 minus 1 plus 5. Well, that means I'm going to have 2. 3 minus 1 is 2. A sub 2 plus 5. Well, do I know what a sub 2 is? Up here, I figured out that a sub 2 was equal to 11. So I simply plug that 11 in to my a sub 2. That gives me 2 times 11 plus 5, or 22 plus 5 is equal to 27. And then the process continues. A sub 4 is equal to 2 times a 4 minus 1 plus 5, which is 2a sub 3 plus 5, which is equal to 2 times, well, what is a sub 3? It's 27. So I write that. 2 times 27 is 54 plus 5 equals 59. And we can keep going on as many times as we need to. However, they only ask for the first 4 terms. My first 4 terms are 3, 11, 27, and 59. Again, we have a sub 1 is equal to 2. Now this one's written a little funny. They have a sub n plus 1 is equal to 3a n minus 5. Well, think about it. Up above, isn't that exactly what we're doing? 1 plus 1 was 2, plus 1 is 3, plus 1 is 4. So if you look up above, we are basically doing the n plus 1 on our own. So if I say a 1 plus 1, that's going to mean a sub 2. Well, what does a sub 2 give me? 3, a sub 1 minus 5. Well, what was a sub 1? A sub 1 is 2. So that gives me 3 times 2 minus 5, which is equal to 6 minus 5, or 1. And we just can keep continuing the process. We had 1 and then 2. So we'd say a 2 plus 1 is equal to a to the 3rd term. That's how we got 3. That gives us 3 a sub, what did we replace the n with? We replaced the n with a 2. So a sub 2 minus 5. Well, that equals, what was a sub 2? A sub 2 is simply 1. So we say 3 times 1 minus 5. And that gives me 3 minus 5 is equal to negative 2. And then we continue the process. A 3 plus 1 is equal to a sub 4. That gives me 3 times, what did I replace the n with? I replaced the n with the 3. So a to the 3 minus 5. That gives me 3. What was a to the 3? It was a negative 2 minus 5. And that gives me negative 6 minus 5 is equal to negative 11. So my first four terms are 2, 1, negative 2, negative 11. Now there are two very important types of sequences that you should have memorized. The first of the two is the arithmetic sequence. That is a sequence that goes up or down by the same amount, called the common difference. Each term is explicitly defined by this equation right here. A sub n is equal to a sub 1 plus n minus 1 times d, where d is that common difference. Now think about it. What does the word difference mean in math? Well, difference means subtraction. And so that's exactly what we're going to do. We're going to subtract it once. Now the second thing I want you to see is look at this formula. Does this look familiar in any way? You're going to say no, but the reality of it is you have seen something similar. What if I wrote y equals mx plus b? Now here we can start making comparisons. A to the 1 would be our b. So when we're graphing lines, they match. Our common difference would be our slope, how much we move each time the x value changes. And then our n minus 1, that's basically n as our variable, that would be our x. So if you have a first common difference, we have a linear function, and we'll utilize this more in later chapters. But for now, understand that when you have an arithmetic sequence, you have a common first difference, and that's a linear function. So here's a couple examples. First one, determine whether each sequence could be arithmetic. If so, find the common first difference and the next term. You do this by subtracting. What is negative 4 minus 10? So you literally say negative 4 minus a negative 10. Well, two negatives make it positive. 10 take away 4 is 6. So common difference is 6. And then you keep going for the next term. From 2 to negative 4. 2 minus negative 4. Well, two negatives make a plus, which gives you positive 6. So to go from negative 4 to 2, I add 6. Now from here, we could probably do it in our heads. How did they get from 2 to 8? They simply added 6. How did they get from 8 to 14? They added 6. And what is the next term? Well, 14 plus 6 is going to be 20. So is this an arithmetic sequence? Yes, it is. What is our common difference? Our common difference is 6. If we were to write the formula, we would say a sub n is equal to, our first term was negative 10. Negative 10 plus n minus 1 times 6. Now they wanted the next term, so we would say that the next term is 20. Always make sure that you answer the question. They wanted three things: the common difference, the arithmetic sequence, and the next term. That next term was 1, 2, 3, 4, 5, 6 term. So you'd say a sub 6 is equal to 20. Now let's do it again. If I want to figure out what the difference is between negative 5 and 2, you'd say negative 5 minus a negative 2. That would give you negative 3. So from here to here is negative 3. Now from negative 11 to negative 5, negative 11 minus negative 5, those become plus. Negative 11, 5 gives you negative 6. So from here to here is negative 6. We can already see that these terms are different. So determine if this is an arithmetic sequence. No, it's not. And our answer would be no, it is not an arithmetic sequence. Next example says find the 12th term of the arithmetic sequence. First, we need to figure out, is it an arithmetic sequence and what is the formula? So we subtract. 14 take away 20. 14 take away 20 gives me a negative 6. 8 take away 14. 8 take away 14 gives me a negative 6. And do one more just to be sure. 2 take away 8, we can do this in our head, negative 6. So we know that our D, our common difference, is negative 6. We know that our first term, a sub 1, is equal to 20, because I can see that there's a 20 right there. Now we can write our formula. A sub n is equal to 20 plus n minus 1 times negative 6. I put the negative 6 in parentheses because there's a negative there. They want to find the 12th term, so I simply find the 12th term. A sub 12 is equal to 20 plus 12 minus 1 times negative 6. A sub 12 is equal to 20 plus 11 times negative 6. 20 plus negative 66. 20 take away 66 is negative 46. So our 12th term is equal to negative 46. Next we have geometric sequences. A sequence that when divided by the term before it will always give the same number. It's called the common ratio. Each term is explicitly defined by the equation a sub n is equal to a sub 1, meaning your first term, r, your common ratio, raised to the power of n minus 1. Common ratios have exponential equations. So see the exponents? It's an exponential equation. Here's our first example. Our first term is 128. Our second term is 64. We divide 64 divided by 128 equals 1/2. Do it again. 32 divided by 64. 32 divided by 64 is equal to 1/2. We'll do it one time to be safe. 16 divided by 32. 16 divided by 32 is equal to 1/2. Now, this is important. We said that it's the second term has to be divided by the first. If you go backwards, you'll have an upside down fraction, and then you'll get the answer wrong. So does this have a common ratio? Yes, our common ratio is 1/2. Now let's build the equation. A sub n is equal to our first term, a sub 1. What is our first term? Our first term is 128. So I'm going to write 128 times our common ratio. We said our common ratio is 1/2. I put 1/2 in parentheses because it's a fraction. Raised to the power of n minus 1. This would be our geometric sequence for that set of numbers. Then they can ask us any number they want. We can plug it in and figure out what the value will be. Here's another example. They say find the 7th term of the geometric sequence, and they gave us some to begin with. So we start by dividing. So 12 over 3 is equal to 4. Do it again. 48 divided by 12. 48 divided by 12 is equal to 4. Just to be safe, 192 divided by 48. This is where calculators come in handy, and that gives you 4. Now we write our geometric sequence. A sub n is equal to, our first term was 3. Our r value is 4. I still like to put it in parentheses. Raised to the power of n minus 1. They're asking for the 7th term. That means n is equal to 7. 7th term, n equals 7. A sub 7 is equal to 3 times 4 to the power of 7 minus 1. That means you have 3 times 4 to the power of 6. At this point, you definitely are going to need a calculator. That's going to give you 3 times 4096, which equals 12,288. So 8 to the 7th, our 7th term, would be 12,288. So to recap what we just did, some basic rules. To find the nth term of a sequence, you do two things. First, you look for the difference between each term. If it matches, then we know it's an arithmetic sequence. If it doesn't match, then we start dividing each term by the term before it. If it is the same number each time, then it is a geometric sequence. This is how you determine which one you're going to need. Most problems are simply going to give you a set of numbers, and tell you to find the sequence. When they ask for an n term, all they're asking you to do is find a sub n equals. Basically, find the nth term means creates the equation. We start by subtracting. 5 minus 3. 5 minus 3 is equal to 2. So that's 2. 7 minus 5 is also 2. 9 minus 7 is also 2. So because we have a common difference, we know that this is a arithmetic sequence. So a sub n is equal to a1, which is our 3, plus n minus 1 times our common difference, which is 2. Moving on to the next one. We'll start by subtracting. 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 11 is 3. Notice how I'm going backwards. We're finding the difference, so we're subtracting. We have a common difference, so it's going to be, again, an arithmetic sequence. A sub n is equal to, our first term was 5, plus n minus 1 times our common difference, which is 3. Next, we try subtracting. 6 minus 2 is 4. 18 minus 6 is not 4. In fact, I don't even care what it is. It's not 4. The fact that it's 12 doesn't matter. I do not have a common difference. So we get rid of those and we try dividing. 6 divided by 2. So 6 divided by 2 is equal to 3. Do it again. 18 divided by 6. 18 divided by 6 is also equal to 3. And for completion's sake, do it one more time. 54 divided by 18 is also equal to 3. So now I know I have a geometric sequence, which means I have a to the n is equal to a1 r n minus 1. So our a1 was 2. A sub n is equal to 2. Our common ratio is 3. And our exponent is n minus 1. All right, now you're probably looking at this thinking, oh my goodness, fractions. And I agree, fractions aren't fun, but we can make it easier. Simply divide the top and the bottom. So treat them like almost two separate problems. So the first one, always subtract. 3 minus 2 is 1. 4 minus 3 is 1. 5 minus 4 is 1. What that gives us is a common difference of 1. On the top we can say our first term is 2 plus n minus 1 times our common difference is 1. Now let's think about this really hard. A common difference of 1, do I really need that? No, of course not. Since the 1 becomes invisible, standing outside the parentheses, I'm going to go ahead and get rid of it and combine like terms. Well, I have a negative 1 and a 2, so I can simply combine those like terms. Remember, we always write our answer in simplest form. Here, our simplest form would be n plus 1. Reason being, I have a 1 as my common difference. Then we go ahead and do it on the bottom. 7 minus 3 is 4. 11 minus 7 is 4. 15 minus 11 is 4. So again, my original term was 3 plus n minus 1 times our common difference of 4. Now, since the top one got simplified, I feel inclined to simplify the bottom. Do you have to? Not necessarily, but it will look prettier if you're looking for a pretty answer. That would give us 3 plus 4n minus 4, which would give us 4n minus 1. But if you left the problem like this on the bottom, that's perfectly fine. Let's try that again. We split it in half. 4 minus 2 is 2. 8 minus 4 is 4. Oh, there's not a common difference, so we start over. And now, since the difference didn't work, we try division. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. So I know I have a common ratio of 2. So I have a sub n is equal to, our first term is 2. Our r was 2 also. To the power of n minus 1. Over and then do the same thing on the bottom. 9 minus 3 is 6. 27 minus 9 is not 6. So I try division. 9 divided by 3 is 3. 27 divided by 9 is 3. 54 divided by 27 is also 3. So my initial term is 3. My ratio is also 3. So I have 3 to the power of n minus 1. Now looking at this, some of you might say, wait a second, can't I simplify it? And yes, you can simplify it. The exponent on this is n minus 1. Well, what are the exponents on the 2 and the 3? The exponent on this 2 is the invisible 1. The exponent on this is the invisible 3. Well, aren't 2 and 2, aren't they like bases? What happens when you multiply like bases? For example, if I did a little side problem, x squared times x cubed. We learned before that x squared times x cubed is equal to x to the 5th power. You simply add the exponents. Well, shouldn't I do the same thing here? Of course I should. So I'm going to be adding the 1 plus n minus 1. So let's do that as a side problem. 1 plus n minus 1. Well, what's 1 minus 1? Is 0. So that would simply give me n. And we're going to do that on both the top and the bottom. 1 plus n minus 1 is going to give me just a plain n. We do this, again, because like bases, add the exponents. Like bases, add the exponents. And that gives me a simplified answer of 2 to the power of n over 3 to the power of n. Moving on. Here, they gave me all fractions except for the first one. It's a whole number. Well, aren't all whole numbers actually fractions over an invisible 1? Now I do the same thing I've been doing. 7 minus 4 is 3, 3, 3. I have a common difference of 3. A sub n is equal to, if it's a common difference, then it's an arithmetic sequence. Our first term was 4 plus n minus 1 times our common difference of 3 over. Now I do the same thing on the bottom. 2 minus 1 is 1. 4 minus 2 is 2. They're not the same. So I need to try division. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 4 is 2. Now I have a common ratio of 2, which means the bottom one is a geometric sequence. So we have our first term was the invisible 1. Our common ratio was 2 raised to the power of n minus 1. Now, the 1 in front, do you need to show a 1 in front? No, you don't. So because I don't need to show the 1 in front, I can get rid of the parentheses also, and I can rewrite it a little simpler as n minus 1 on top. So we have a arithmetic sequence on top and a geometric sequence on the bottom. Now they say find the 8th term of the following geometric sequence. So first we need to find the common ratio. We already know it's geometric, so we know it's going to be a ratio. What's negative 5 divided by 10? Negative 5 divided by 10 is equal to negative 1/2. Do it again. 5/2 divided by negative 5. Here I'm dividing fractions over invisible 1. You should know how to divide fractions by now, but here's a quick review. 5/2 divided by negative 5, which is a fraction over 1. 5/2 times negative 1/5. We invert and we multiply. 5's cancel out, gives me negative 1/2. So I've confirmed that my common ratio is equal to negative 1/2. A sub n is equal to, my original term was 10. My r is negative 1/2 to the power of n minus 1. So they want to know what the 8th term is. So we say a sub 8 is equal to 10 to the power of negative 1/2. 8 minus 1, 10, 1/2 to the power of 7. Well, 1 to the power of 7 is 7. Negative to the power of 7 stays negative because it's an odd exponent. So I have 10, negative 1 over 2 to the 7th power is 128. 10 times 1 over 128 simplifies to negative 5 over 64. Okay, here's a bonus challenge question. Instead of giving us a sequence, they simply gave us 2 answers, and they want us to find the 10th term. This is how it works. Our normal formula, a sub n is equal to a1 r to the n minus 1. Problem, we don't have an a1. We don't have anything. We have the 5th term and we have the 7th term. So what we're going to do is plug those in. The 7th term is bigger, so I'm going to write that on the outside. A to the 7th is equal to, now instead of using the a1 term, which I don't have, I'm going to use the 5th term. A5. I also don't have an r, so I'm going to keep the r there. Now, here's where it gets tricky. I'm started with the 7th term, so where the n goes, I'm going to put a 7. Here, instead of a 1, I put a 5. So instead of a 1, I'm going to put a 5. And this is how it's going to look. 7 minus 5. I simply substituted what I didn't have with what I did have. Now I'm going to plug in the numbers that they gave us. What is a to the 7th? Well, a to the 7th is 384. What is a to the 5th? A to the 5th is 96. 7 minus 5 is 2. So I substituted 384 and I substituted the 96. Now I need to solve for r. I solve for r by dividing both sides by 96. That gives me r squared is equal to 4. The opposite of squaring something is square rooting. What I do to one side, I do to the other. R is equal to, and if you said 2, you're wrong. R is equal to 2 or R is equal to negative 2. Remember, whenever I'm taking square root, I have 2 possible answers. Now I need the 10th term. So we do the same basic thing. But now I actually have my R. So we can say a to the 10 is equal to, I still don't have an a1, so I need to choose one of these two. A to the 5th is smaller, so I'm going to use a to the 5th. A to the 5th. My R I did find as positive 2. And the top would be normally n minus 1, but this time our n is 10, and instead of a 1, I'm using the 5th. So I'm going to say 10 minus 5. Then I plug in the numbers. A10 is equal to a to the 5th is 96. 2 to the power of 10 minus 5 is 5. A10 is equal to 96. 2 to the 5th power is 32. 96 times 32 is 3072. So a to the 10th is 3072. But that was only for this. I also have a negative version. Everything is going to stay the same except for when I get to the bottom. A to the 10 is equal to 96 negative 32. So a to the 10 is equal to negative 3072. I have 2 answers with an or between them.